Okay, welcome, class. Today we are going to start R5, which is rational expressions. And so we're going to be dealing with the algebraic expressions that are in fractional form. So sort of like these. So these are all examples of rational expressions. So whenever you have a quotient of two polynomials where the denominator is not zero, this is a rational expression. The domain of a rational expression is going to be the set of all real numbers for which the expression is defined. Well, when are fractions defined? Or in other words, when are fractions not defined? So in this case, it'd be easier to say, hey, when are they not defined? And that's when the denominator is zero. So the domain is going to be all real numbers except those numbers that make the denominator zero. So we have to focus on the polynomial that's in the denominator. Okay. For example, if we look at this expression here, we could say that the denominator is going to be all real numbers because, again, the top of a fraction can be anything. It's the bottom of the fraction we have to worry about, which is it can't be zero. So in this case here, when is the bottom zero? Well, when x is equal to -2. So that means x equal to -2 is a restricted value. So in other words, the domain can be anything except -2. And so using set builder notation, we see that the domain is all values of x such that x is not equal to -2. Okay, and so we have to solve the bottom equal to 0. So what values will set that equal to 0? Well, x equal to -2. Okay, now if the denominator contains a product, which means if it's factorable, then we can use the zero factor property. Okay, which means that if we have two numbers, a times b, product of two numbers, equal to 0, that's going to be true if and only if a is equal to 0 or b is equal to 0. This is also known as the zero product principle. Okay, they call it the zero factor principle or property, but it's also called the zero product principle. Okay, now, so if we look at the example here, okay, we look at the top and the bottom. So again, here, the top we don't care about. Okay, we want the domain. So the only part we're going to look at is the denominator. So again, we want to find the restricted values. So in this case here, when will the bottom be 0? Well, we set this equal to 0, and we say, okay, well then in this case we're going to use the zero factor property. Well, this will be 0 if either this factor is 0 or this is 0. So we're going to solve for that equation, and we find that that is true when x is -2 or -4. Okay? Because if x is -4, this becomes 0, and the whole thing becomes 0. If this is -2, if x is -2, this factor becomes 0, and again, the whole thing becomes 0. So that means the restricted values are going to be -2 and -4, like I said. And so we would write, again, the domain in set builder notation. We would say the set of all x such that x cannot be equal to -2 and -4. So go ahead and try these exercises here for practice. Again, if you get stuck on anything, or if you get the wrong answer or you're not sure what to do, we can work them out in class. Okay, so lowest terms of a rational expression. Again, just like we dealt with fractions as kids, and we put fractions in the lowest terms, we can do the same thing for rational expressions. So to put them in the lowest terms, we have to find the common denominator or the common factors of the top and the bottom and see if we can cancel anything. Okay, so we're going to use the fundamental principle of fractions to write a rational expression in lowest terms by dividing by common factors. So the fundamental principle of fractions says that if we have AC over BC, we can cancel and divide out the C's and we get AB. Okay, and of course, AB is going to be in lowest terms. Okay, and again, we're assuming that B and C are not equal to 0. Okay, so here we go. So we're going to use what we know to write these in lowest terms. So here, the first thing we're going to do is factor the top and the bottom. Okay, so again, we're going to use our tools to factor the numerator and the denominator, and we're going to get this. Okay, once we factor that, we look for a common factor on the top and the bottom, and we divide those out because x plus 4 divided by x plus 4 is 1. So that becomes this. Okay, and this is our final expression. Okay, now this here is in lowest terms. Okay, now be careful about the domain though, because the domain is everything before we cancel. So in this case here, there's two restricted values. X is 0 and x is -4. But if we divide this out and we look at this and we do the domain, well, we find that the domain is just 0, which means that we're missing information. So when you're looking at the domain, you look at the factored form before you cancel. But in this case here, they don't ask us about the domain, so they just want it in lowest terms. So we're good. Okay. Okay, now what about this one? So now we have a difference of two squares here. So which means this is going to be factorable into x plus 4 and x plus 2 and x minus 2. And so in that case, the restricted values are going to be plus or minus 2. Okay. Okay, so now we see when we factor the top, right? So we look at the top here, we factor the bottom. Now notice that this is 2 minus x, but we've got x minus 2 down here. If we pull out a -1, pull out a negative sign, this will switch the 2. It'll become x minus 2. So we can then pull out the -1, okay? And hold on a second here. So you get x minus 2, so you get the same thing on the top and the bottom. Okay, so what we do here, now I don't hear the way they're doing it. I would just factor out a -1 here. This would flip this to x minus 2, and then you cancel these two, and you end up with a -1, so -3 times it. Here, what they did was they multiplied the top and the bottom by -1. You could do that too, but you don't need to. You could just factor out a -1 and have the same effect. Okay. And then these cancel, and you end up with -3 over x plus 2. And now what's the domain? Remember, the domain is going to be, in this case, the domain is going to be x equals 2 and -2. Well, those are the restricted values, so the domain is going to be everything except that. Okay? Okay. Now, the fundamental principle requires a pair of common factors, one in the numerator and one in the denominator. Only after a rational expression has been factored can any common factors be divided out. Okay, so for example, if we see this, we factor out the top, we factor at the bottom, and we see we have common factors, and then we cancel. So you must factor first and then divide. Do not try to divide out here and factor this term here. You cannot do it. Remember, you can only cancel across multiplication and division, multiplication and division, not addition. Okay, so be aware. Factor first, then divide. Okay, so next, multiplication division. So here's the properties for multiplication division of fractions. Okay, so if you have two fractions, a over b and c over d, again, b and d are not zero, you can multiply fractions by multiplying across the top and multiplying across the bottom. So AC divided by BD. Division is you have to multiply, you have to change it to a multiplication problem by taking the reciprocal of the divisor. Okay, so this is the divisor. You're dividing by C divided by D. So you're going to change this to a multiplication problem by flipping or taking the reciprocal of the divisor, which is going to change it to D over C. So it becomes AB times DC, and then you can multiply across the top and multiply across the bottom. Okay. Now another way to do this is to do what I call the rule of 4. You can then do cross multiplication, multiply across diagonally, and then multiply across the bottom, and what happens is then you just divide the numerators, because then you get a common denominator, and then it just becomes a division, dividing across the top and dividing across the bottom. But then you get, since these are common denominators, you get 1. Okay, so essentially you just get the cross multiplication, so this becomes AD divided by what? BC. And what do you get here? AD divided by BC. So you get the same answer. Okay. So if we look at these expressions here, so if we want to multiply across, we multiply across the top and multiply across the bottom. And then what we can do is we can cancel. So if you notice here, this 2 will cancel with this 8. So what's the largest value that will divide both? 2. So you can divide this by 2 and divide this by 2. Well, this becomes 1 and this becomes 4. Also, 9 is divisible by 9, and 27 is also divisible by 9. Okay, so this will become 3 and this will become 1. Also, this y squared will cancel out with this y to the 5th. So this can be divided by y squared, which becomes 1. This is divisible by y squared, which then becomes y cubed. Okay, so you can cancel things out and then multiply across the top and the bottom. Or you can multiply across the top and the bottom first and then cancel. Okay, so here, they multiplied across the top and the bottom, and now we're going to simplify by getting common factors, right? So notice that we get 2 times 9 times 3, because the 27 splits up into 3 times 9, and the 9 and the 8 also can be split up. 8 can be split up into 2 times 4. And so now you have common factors here that can cancel, and you've got common factors here that can cancel. And you end up with the exact same thing. Oh, by the way, you can split the variables up into factors too, because this can be split up into y squared times y cubed. And haha, these two cancel, the 9's cancel, and the 2's cancel, and you end up with 3 over 4y cubed. And this is in lowest terms. Okay, so again, and once you do it this way and you get used to it, then you can start seeing how to simplify things here. But again, and if you're not sure, just split it off into factors and then cancel all the common factors, because all of the common factors divide to make 1. Okay, now let's look at this one. So we have this times this. So the first thing we're going to do is we're going to factor to see if we get common factors here. So these can't be factored, so we're going to leave those alone. But let's see if these can be factored. Well, this factors into m minus 2 and 3m plus 4. This factors into m plus 4 and 3m plus 2. Okay? And again, you could do this using the AC method. Okay? Now we're going to multiply across, and we get this here, and now we look at the common factors. Well, this and this are the same. This factor and this factor are the same, so these will cancel out, and we end up with m minus 2 divided by m plus 4. Okay, now division. So in this case here, we're going to change it to a multiplication after we factor. So we're going to factor all the terms, right? So this factors to this, the denominator factors into this factors into this, and this polynomial factors into this. Now that we've got it in factored form, let's change it to a multiplication problem by flipping this fraction. So we flip the fraction. Now we're going to multiply across the top of the bottom and cancel. So this cancels with this cancels with this over here, right? We got to have one on the top, one on the bottom, one on the top, one on the bottom, and then we end up with this. And so now let's continue factoring. Let's make this into common factors. 3 times 4, p squared times p, okay? And this factors into this, right? So now we can cancel this 3 with this 3. This 4 cancels with this 4, and p squared cancels with p squared. And now we get this. Now, other than that, there's nothing else that can be factored or simplified. And so we're done. Okay, now we're going to do the same thing. Okay, so now we've got a difference of cubes that we know how to factor. We've got a difference of squares that we know how to factor. And then we've got these polynomials that we should try to factor as well. Okay, so this becomes this, right? Factors into this. The difference of two squares factors into this. This we're going to factor by grouping. Okay, so if we use these two, we get this, and then group these two together, we get this. And look at this. Now we've got a common factor that we can factor out again. Again, down here we can factor by grouping, and we end up with this down here. And so now we can start canceling things. So this cancels with this term, this factor, these factors cancel, the red factors cancel, and these green factors cancel, and then we end up with this. And this is in lowest terms, cannot be factored any further. Okay, now go ahead and try these exercises and see if you can do the same thing. Again, if you get stuck and you're not sure how to factor them, or you're not sure how to cancel or anywhere, just go ahead and email me or let me know, and we can go over these exercises or these examples in class as well. Okay. Okay, so addition and subtraction. Okay, so now here's where the rule of 4 is used. Now, if they have a common denominator, obviously we just add across the top or subtract across the top and keep the bottom. But where we're more interested in it is when they're not the same, when we don't have a common denominator. Well, what we can do is we can use the rule of 4, which means that we're going to multiply across the top across this way. We're going to multiply across this way, and then we're going to multiply across d times b, and then we're going to multiply b times d. And we're going to use that to get a common. Okay, so in this case here, we end up getting a common denominator because we're going to end up getting BD over here and BD over here. And if we cross multiply, we get AD over here and BC over here. And so we add across the top and keep the bottom. And by using the rule of 4, we end up getting this new fraction. Same thing when we subtract. We're going to use the rule of 4 and just keep the subtraction sign, and we end up with this expression here. And so this works for any fractions, whether polynomial or whole numbers. This is the same method that we use. Okay, now we can also look at finding the least common divisor. Okay, the least common divisor as the denominator, and that will also make sure that we simplify the fraction and have it in lowest terms if we use the LCD, the lowest common divisor. Okay, let's see here, or least common denominator. Okay, to find the least common denominator, we write each denominator as a product of prime factors. And then what we do is we form a product of all of the different prime factors that we find. Each factor should have as exponent the greatest exponent that appears on that factor. Okay? To find the least common denominator. Okay? So here's what we're going to do. So example 4, so in part A, we want to find, now we could do the rule of 4 and just cross multiply and multiply across, but let's get the least common denominator in this case here. So if we look for the least common, we're going to put these in factors. Okay, so these are already in factors. You can't really factor, except here we could factor this into 3 times 3 and this into 2 times 3. And then we see that if we, the lowest common divisor is going to be the greatest exponent of these. So if you look down here, we look this as 3 squared times x squared, so it's in their prime factors. And then 6x becomes 2 times 3 times x. And what we do is we take all of the ones that have the largest exponent. So 2, the largest exponent with base 2 is 1. So we're going to keep this one. The largest exponent with base 3, prime 3, is going to be this one. And then the largest exponent of the variable x is going to be this one. So the least common denominator that we're going to end up with is going to be 2 times 3 squared times x squared. And we get 18x squared. Okay. And now what we're going to do is we need to find a way to get 18x squared. So how are we going to make this 18x squared? Well, we multiply by 2. Okay? And if we multiply the bottom by 2, we have to multiply the top by 2. And so to keep the fraction the same, right? Remember equivalent fractions. Now, what about this one? Well, we need an 18x squared. So we're missing an x and we're missing a 3 as a factor. So we're going to multiply the bottom by 3x and the top by 3x. And now we end up with this. Now we've got a common denominator, and so now we can add the top and keep the bottom. And this is what we end up with. And we're done. It's in lowest terms. Now, if we would have just did the rule of 4 and cross multiplied and multiplied across here to get the common denominator, we would have gotten a different expression, but it would not have, it would have been correct, but it would not have been in lowest terms, and then we'd end up having to factor out a common factor anyway. If we do it this way by using the least common denominator, then we ensure that our answer is going to be in lowest terms. Okay, so let's look at this one. So here we are. So we've got these two, we want to add them. So we want to get a common denominator. Now in this case here, notice that this is y minus 2 and this is 2 minus y. So all we're going to do is we're going to factor out a negative 1 to flip this, okay? Because this is the same as 2 minus y times negative 1. or excuse me, this is the same as y minus 2 times negative 1. Okay, now again, they multiply the top and the bottom by negative 1 to get this to flip to look like this, which is fine. Okay, either way, 6 half a dozen or the other, you're still going to get the same answer. Okay, so then this becomes a negative 8, this becomes y minus 2, so now you've got a common denominator, right? And you get y minus 8 over y minus 2. Okay. So now let's look at this one. Okay, so you could have done it this way. You could have multiplied the top and bottom by negative 1 here, flipped this one, got them to be the same, and you would have still ended up with the same result. Okay? So let's look at this one. Now, this is already in factored form, right? These are prime factors. So what's missing? How do we get a common denominator here, right? Well, this is x minus 1. They have nothing in common. So in order to get the least common divisor, we're going to have to multiply all 4 factors together. Okay, so the least common divisor is going to be this thing right here. So how do we get this over here? Well, we're going to multiply the top and the bottom by these 2 factors. And how do we get these 2 over here? Well, we're going to have to multiply the top and the bottom by these 2 factors. And so what happens is we're going to get this over here, and we're going to get 3 times this over here, right? So we're going to get this, right? So now we've got the missing pieces over here. So we're multiplying the top and the bottom by these 2 factors. And over here, we're multiplying the top and the bottom by these 2 factors. And so now we've got a common denominator that now we can subtract across the top, which we did here. Okay? Okay. Now they went ahead and expanded this out, multiplied this out, and multiplied this out. Okay, which is fine. And so you get 3 times this minus this. Okay, so now we're going to distribute the negative sign here. So this is going to be negative or minus x squared minus x plus 2. So that's where this comes in. Okay, and we're going to distribute the 3 over here. So this is going to be 3x squared minus 3x minus 36. And so we get this. So the numerator becomes this. So again, be careful of the signs. Okay, now we're going to combine like terms, and we end up with this as our final result, and this is in lowest terms. So now you could try these 3 problems here as practice problems. And again, if you get stuck or you're not sure how to do it, let me know. Email me your work. I can take a look at it. We can also work these throughout in class. Okay, now complex fractions. Okay. Well, what if we have something like this? Well, we're going to have to get a common denominator, right? So we can do this a couple of ways. We can multiply the top and the bottom by k, or we can get a common denominator here and then divide. Either way is fine. So if you multiply the top and the bottom by k, because why are we doing that? We're trying to get rid of this denominator here. So since the only denominator is k, we can multiply the top and the bottom of this fraction by k, and we'll get 6k minus 5 on the top, and we'll get k plus 5 on the bottom. Okay, so this is method 1. Okay, so we multiply the top and the bottom by k, and we use the distributive property, and we get rid of the fractions, and it becomes what? 6k minus 5 over k plus 5, and we're done. Okay. Now, there's another method that we could use, which is, again, we could just get a common denominator. So let's look at, oh, hold on a second, hold on, I just want to double check, make sure I didn't miss anything here. Oh, hold on, I went too far. Okay, so that's good. So now on the next one, what we're going to do is we're going to use this one. Okay, so we could do the same thing. We can multiply the top and the bottom by the common denominator. So here we got a and a plus 1. And we've got a plus 1. So we can use the least common divisor, this product right here. And we can multiply the top and the bottom by the least common divisor. And what's going to happen is we're going to use the distributive property. And the distributive property is going to cancel this with this. So we're going to get a squared. And then this a is going to cancel with this a. So we're going to get a plus 1 right here. And then the bottom, a is going to cancel with a, so we're going to get a plus 1 plus, and then this is going to cancel with this, so we're going to get a down here. So we're going to end up with this when it's all is said and done. Now we're going to simplify. Drop the parentheses here, we get this one. Drop the parentheses here, we get 2a plus 1, and we end up with this as our final answer. Okay, now another method, right, is to find the least common denominator and add terms in the numerator and denominator of the complex fraction. So here's what we started with. Okay, so we get a lowest common divisor on the top again. So by using what we know, so this is going to be the least common divisor. So we multiply the top and the bottom by what we need to get the least common denominator, the lowest common denominator. Okay, so here we're missing an a, so we were going to multiply the top and the bottom by a, and then here we're missing a plus 1, so we're going to multiply the top and the bottom by a plus 1, and we get a common denominator, and this is what we end up with. We do the same thing on the bottom, and we get a plus 1 plus a, right? So we got using the rule of 4 or using the least common denominator, and so we get this denominator. Okay, now this is what we end up doing. So method 2 says, now that we've got a fraction with a common denominator here that's the same as the denominator here, now we're going to multiply by the reciprocal of the bottom. Okay, so we're going to change this to a multiplication problem. Now notice that if we multiply across the top and the bottom, we've got a common denominator on the top and the bottom. So we can cancel this with this, and we end up with the same result. Okay, so again, 2 different methods get the same results. Okay, and that wraps up this section. And next time we're going to start with the review section for R6. Okay, until then, if you have any questions, email me. If you get stuck in any of these examples or the exercises that you can try for practice, let me know and we can work them out in class. The more we practice, the better you're going to be at these. Okay, have a great day.